Greetings and welcome, internet friends. Me and my algebra buddies hanging out. We've been learning how to factor for like a week and a half. It's been incredible. We've become such great friends. We've worked through difficulties together, and having a common struggle has brought us together as some sort of mathematical family, perhaps. And we've become the best of friends. And now we're going to use all of our skills, combining them together for the sake of destroying these problems, factoring them completely. We're going to have to know when to use GCF, when to use the AC method, when to use the difference of squares pattern. And all of our powers combined, we're Captain Planet. So here we go. Factor the polynomial by grouping. And so notice, this actually factor by grouping, all we're doing is the last two steps, the last step of the AC method. Find the factors of the first two terms, steal out a y guy right there, and the last two terms. There ain't nothing in common. Oh, thanks. Now, internet friends, one of my students literally just called me bro when they kindly corrected my mistake. I could steal a y squared from that. Thank you. You are also my brother, as well as Hulk Hogan, apparently. So let's see, +1 and then parentheses. There we go. And so y squared times y minus 9, and 1 times y minus 9. Notice those yellow parentheses match, which is necessary in order for factor by grouping to work. So let's write our two factors. I've got the y squared plus 1 and the y minus 9. Is that y squared plus 1 further factorable? Oh, I want it to be oh so bad. Except there's no such thing as the a squared plus b squared pattern. No, says Michael Scott to Toby showing up. That is not a pattern. Impossible. All right? So that's, it's tempting, but it will not work out. And we'll find out later on in this course that if I set that equal to 0 and tried to solve, I would get imaginary answers, says SpongeBob, forming a rainbow over his head as his hands move in an arc-like fashion. All right, so this one, I'll just speed run this. I can't factor by grouping effectively until I rearrange this. I'm going to put this in standard form. And once it is in standard form, oh, now the first two terms and the last two terms are quite factorable. All right, did I mess up? Oh, my 2's and z's, I apologize, and that's an x. Yeah, I wrote, yeah. It's all right. Feel free to comment below about any other errors that I make throughout this video. Also, feel free to make a mega edit of all the sound effects that I do throughout and turn it into a dubstep song. This audio is now free license for anybody. So let's see. Let's keep going. Let's steal the common factor between these, and my brother would tell me I could steal a z squared as well as that 3. Actually, my younger brother Carl just took a test for firefighter work in Seattle. Flew down from Juneau. True story. Wonder how he's doing. Hey, brother Carl, comment below. Talk to me. Hope to see you when you get married. And boom, z minus 4. Yeah, that was a shout out to my brother Carl. He's my bio brother. He's way cooler than I am. Bio means biological. Although, possibly biohazardous, which my older brother Jay did just get a new job where he manages the transport and storage of hazardous materials, both biological and radioactive, etc., chemical things like that. So there we go. Is this further factorable? A student may have said something, but they were still wearing AirPods, so I couldn't hear their response. That's weird. So let's see. Now we get into the meat of this. This is where it gets real. Oh. So let's see. Step 1. See if I can factor by grouping. A yoink. I think I can steal a 4a squared. Now, you might have, maybe you use the difference of squares pattern right out. I consider it slightly harder. Let's see if we arrive at the same spot. There's a potential for a mistake at the end of doing the difference of squares first, although you can do difference of squares first. But we'll see if we get the same result. And I wouldn't mark you wrong if you did it that route and then remembered to GCF at the end. So 4 times 9, I'm told, is 36. A squared times a squared would give me that a to the 4th. And minus 1. And notice, this does have me thinking about that difference of squares pattern. The inside there is further factorable. And so my little flow chart that I equipped mis estudiantes with, right, Yoshi? That's right, internet friends. I have a student named Yoshi. In fact, for all my internet friends know, I'm teaching to a room of Mario-themed stuffed animals in my basement. So A would be 3A, and B would be 1, and it matches the difference of squares pattern. That's such a disturbing thought. I don't know. I weirded myself out with that one. Someday that will be all I do in retirement. Well, I mean, feel free to share this recording with him. Let's see. Here we go. And I think I've factored completely. Well, don't worry. We're going to keep training all day today. It's going to be good. 4a squared is a single term, so I can't factor it any further. Okay. So, alt world. You might have had, let me see if I can guess it. Did you have like 6a squared minus 2? All right. Yeah, I'm actually, my brain is stumped on this. Oh, okay. So you ended up, here, quiet please, attention. You ended up applying the bottom pattern second half when you should have applied the top pattern, the difference of squares pattern. So what you would have had was this, I believe, if you had applied the pattern. And then you would have been able to further factor out a GCF. So you would have been able to steal a 2a here and a 2a there. Yeah, you can write a pass. And 2a times 3a plus 1 times 2a times 3a minus 1. Here, I've got a... Guys, the math got so real, someone started bleeding out of their face. They're okay. I'm a first responder, but I'm not very good at it, and I normally faint when I see blood. So, I probably become more of a liability than an asset on a accident scene. True story. Yeah, Koopa Troopa, that's enough. Are you a red or a green one? Because some of them walk off a cliff and the others turn when they reach the edge of it. So Luigi, did you see where, when I GCF'd that, Luigi, that the 2a's when multiplied would have given me 4a squared? You didn't plug it into this part of the pattern. You plugged it into this pattern, and so you ended up using the wrong pattern at the wrong time. But I'll visit you when we're doing group work later. All right, 15. Let's keep cruising. Let's see, where are we at? We're at 9 minutes 31 seconds, folks. Let's keep going. Welcome. So let's see. Step 1, GCF. Between all of these, I could steal a 6G. Yeah, concurrence. Yep. And on the inside, I would have G squared minus 4G plus 4. Now, that yellow part, I still can't hear over the AirPods. That's weird. That yellow part is further factorable, though, the rest of us. And there's actually a couple ways you could do it. You may have noticed that it matched a pattern. It's a perfect square trinomial pattern. So I'll show you, right? A squared plus or minus 2ab plus b squared equals a plus or minus b all squared. So you could have used that pattern, but you also could have, to be honest, you could have just found the factors of c that add to b. And that, I feel, is a lot easier in this particular case. Either route would work just dandy. So I'm going to have a g with a, I want them, the 2 and the 2. Root it to 2. Andy Bernard reference. 6g. Now, you probably wrote it this way? Or were you splitting the b term? You could split the b term. Yep. Now, because the number in front of the g squared was 1, you don't have to split the b term. Although, yes, you can use that route and you'll still get to the same answer. You could have jumped right into this pattern as well. So there's multiple approaches to these problems, all right? There will, maybe some people would have written it this way, and then I would have hoped that they would have combined the matches into being a square. All right. Okay, and then just make sure, don't let the internet friends know that they have secret problems they're not going to be able to see. All right, like an alternate exit in a Mario level, like, please, secret. All right, so here we go. The volume of a prism, and make sure, Bowser, you're not using a cell phone in your sweatshirt back there. Let's see, we've got the volume of a box, prism, perhaps, is length times width times height. Length times width times height. Right. And that's equal to the volume. Man, that was squeaky, squeaking like that SpongeBob episode when he had those boots and he said, "May I take your order?" and boot squeak. So let's see. Let's fill this in. So W plus 4 times W times 4. And I guess that's kind of weird that I wrote it backwards. And I happen to know that the volume of the entire box is 128 cubic inches. And all of these are in inches, so my units matched up. It's wonderful. So let's see. Tell you what, I have a feeling you guys are probably annoyed in the way that I wrote that. You don't have to write this middle step. You could have just gone right into distributing. But W times 4 is 4W. And we typically like to distribute from the left to the right because not all languages do that, but, the left to right, the right to left. Whatever, it's fine, it's fine. Either way. So, question? Yeah, I just rearranged it to make it a little bit more obvious. But you don't have to write that step. 16 dub equals 128. Now, you might wonder, well, why did I even bother distributing this out in the first place? It was already factored. Why couldn't I have just set each factor equal to 128? But there's no such thing as the 128 product property. No, it's the 0 product property, ZPP. And so I'm going to, I have to distribute this out, and I've got to set this equal to 0 in order to solve by factoring. And by the way, in a couple chapters, we'll be solving using multiple approaches, and even non-factorable problems will be solvable. Even problems with imaginary answers will be solvable. We're just solving by factoring. So I'm setting up for the ZPP, and now we've got a bunch of choices. How do I factor this? I think I can GCF. Is a 4 going to 120? Oh, yeah. 128's like a power of 2. The power of 2. Yoink. And so let's see. I'll be left with Oh, wait. I could steal a 4. That's even greater. I'll tell you what. I'll keep my 4 in the purple. Start wearing purple. W squared plus 4 dubs minus... Someone help me out here. Divide by 2 would be 64. 32. Now, since the W has a positive 1 leading coefficient, I don't have to do AC method, although I'm able to. I'm just going to find the factors of 32 that subtract a 4. And if you don't remember that route, then use AC method. It'll be fine. 2 and 16. That's why we've got the flow chart, and that's why we're going to become masters of the universe over the next few days. Knowing which method to use when will be significant. Question. I'm not. You're welcome to. You'll get the same route. Same outcome. Mine only works whenever it's a leading term of 1. Yep, we'll go back in a moment when we're all doing full review, and I'll remind everybody how to do that method. That was the first method we learned to factor before we had A times C. Do I have all the factors here, 4 and 8? Yeah. And I want the ones that subtract to be... Oh, anyways, I got them right there. And so, right, you could split the B term and do that. It's even faster... where I'm going to just break this into 2 sets of parentheses. One will be a W with the 4, and one will be the W with the 8. And I choose the signs of these in the same logic as when I split the B term. And correct, this only works when the leading coefficient, the number in front of the squared, 1. And so AC method works all the time. And this is a little bit of a time saver, but you don't have to do it this way. So I think I get -4 and +8. All right, we're about to finish this video. So all of these things multiply to equal 0. And according to the zero product property, I could now set each of those things equal to 0. Equality to 0. I would agree. Yeah, 4 equals 0. That's garbage. And that's not an X. That's a W. So anytime I have the product of a bunch of things that equal 0, one of them must be 0. And I agree, as someone just pointed out, 4 doesn't equal 0. Yep. And so you didn't even have to write that part if you don't want. Well, I'm trying to solve for the variable that the word problem's trying to help me out with. Nothing. It's just that wasn't an answer. And there is actually here, well, it doesn't make sense, and that's why I rejected it as an answer. Just like W equaling -8 is an algebraic solution, but a birdhouse with a -8-inch width doesn't work. And so I'm rejecting this answer, and I'm rejecting the no solution answer. If it doesn't make sense, I reject it. Right? Yeah. So W equals 4. What does that mean? So W equals 4 inches is one dimension. So the dimensions of the birdhouse are 4 by 4 by what? What's this dimension? Yeah, 4 plus 4, 8. Right? So 4 by 4 by 8 would be my answer for the dimensions of said birdhouse. Yeah, bingo bongo. Oh, I mean, not doing the work and not getting the answer also is always an option in life. Early surrender. I used to say, you might have had some mathematical intuition that could have arrived at the 448 earlier on. I agree. But there also could have been multiple ways for that to work, which actually this did have multiple ways for it to work, but one of them was negative. Yep. And that divided by 4 on both sides is a great idea, right? If you divided by 4 right away, It's accomplishing the equivalent of that later GCF. But no, that's a great insight, and that would have made the problem easier. All right, well, internet friends, I'm out of here. Me and my friends in real life are going to hang out, do algebra. Have a great day. Adios.